All right, thank you for joining. My name is Jason Selnow, and today we'll be talking about compounding and also discounting. I'm a partner with Oak Hill Business Partners. Our home office is located in Brookfield, which is part of the greater Milwaukee area, and we serve clients within greater Milwaukee and outside of greater Milwaukee. My role in my career over the last 18 years or so has been that of a controller, CFO level for businesses, and at Oak Hill Business Partners, I serve in what is called a fractional CFO role for businesses. Essentially, whatever they need me on a weekly, monthly basis, I'm there to provide that support in an operational finance role. Let's start out today talking about compounding first. That seems to be very intuitive for people. Over time, as they have their money invested, it increases. That balance compounds over time. So let's talk about that. If we're to start out with, say, $10,000 now, today, and have that grow at a 10% rate of return, what amount is that? How much does that compound to in, let's say, for example, 3 years? So we can say, okay, well, $10,000, 10% of that, at the end of the first year, we're going to add $1,000 and have a total of $11,000. Then that amount is going to grow at a rate of 10%. So in year two, we're going to add $1,100. So at the end of year two, we're going to have a total of $12,100. We take that amount times 10%, add it to it, or take 12,100 times 1.1, and we're going to get $13,310. Now there's some math that's going on behind the scenes here. So what we can do is we can say in year one, $11,000. We know that it's going to grow to be $11,000. That factor of 11,000 that we end up with to the 10,000 that we started with, that factor is 1.1. Then that is going to grow in year two again times 1.1. So we can take 10,000 times 1.1 times 1.1, or we can simply take 10,000 times 1.1 raised to the second power. Okay, and that little hat symbol is above the 6 key on your keyboard. And so in Excel, what that does is it raises 1.1 to the second power. So the factor, if we're going to go out 2 years, is 1.21. We do the same thing for year three. We can take 10,000, do it the long way, just like we did in the previous slide, or take 10,000 times 1.1 raised to the third, which is 1.331, giving us $13,310. So that's pretty intuitive, nothing really new for most people. Discounting, however, seems to leave people with a lot of question marks. Discounting is simply the exact polar opposite. It's the inverse. We're going to start out by using the numbers from the previous slide, but if we know that in 3 years we're going to have $13,310, and we're going to assume an interest rate of 10%, how much is that today? Well, we're using, numbers from the previous slide, so obviously that's going to be $10,000. So let's change it up a little bit. What if we know that in 3 years we're going to have $20,000? We have a choice. Someone says, in 3 years, I'll give you $20,000, or today, $15,100. Which one would you choose? Well, if we're going to discount $20,000 to the present, what we would do is take $20,000 and divide it by our factor of 1.331. And if we did that, we would get a total of $15,026. Now that's less than the $15,100. So these are the types of choices that we start to face when we are dealing with finance and financial transactions. But what if that discount rate was 9%? Okay, so we have to wait 3 years to get $20,000, but if our discount rate is 9%, that changes our factor. Okay, 1.09 raised to the third power, you'll see in the upper right-hand corner, the factor is 1.295. So when we divide, we take 20,000 divided by 1.295, we actually get $15,444. So if we were faced with a decision between $20,000 3 years from now or $15,100 today, with these assumptions, with a 9% discount rate, the net present value is higher if we wait the 3 years to get that $20,000. Obviously, there's other risks involved, but we are just strictly talking about discounting interest rates today. So at 9%, $15,444 is the present value. Now, let's go back to elementary school a little bit, and we would always double check the answer, right? So if we were to start out with $15,444 and add 9% to that, at the end of year one, we would have $16,834. Again, we compound that at 9%. At the end of year two, we'd have $18,349. And compounding that again, that $18,349 at 9% at the end of year three, we would have $20,000. Or we can simply take $15,444 and multiply it times our factor of 1.295. Again, that 1.295 is 1.09 raised to the third power. Now, moving forward a little bit, let's say to Algebra 1, when it was rare, anybody that really liked Algebra 1, everyone was always asking, well, why do I need to know this? So here's the why do I need to know this. Let's change this up a little bit, and let's say we're going to take a look out 10 years into the future, and we're going to decide we need $1 million to retire, and that's 10 years from now. Do I have enough saved today in order to reach that goal? And we've decided that a 7% rate of return is what's realistic. So using these assumptions, what we're going to do is we're going to discount that $1 million back 10 years to today. And if it's going to grow at 7%, do we have enough money that we're starting out with in order to reach that goal? Now, again, we're dealing with a different interest rate. We've gone with 10% and 9%. Now we're dealing with 7%. So if we're dealing with 10 years, we have a factor of, we start out with 1.07 and raise it to the 10th power, giving us a factor of 1.967. So if we divide $1 million by 1.967, that gives us a present value, discounted to today, of $508,349. $508,349. So if we have more than that, when we look up our brokerage accounts, wonderful. Looks like we're going to reach that goal. If we're only sitting on 50 grand, then, right, we've got some cold water hitting us when we're in the shower as to some reality as to where we are relative to reaching that goal in 10 years. So that's just one quick example, maybe a little bit anecdotal, but I think it's relevant to most conversations within, talking with your financial advisor. Now, with Excel, again, in the previous webinar, there was a function called present value. So if you type into Excel equals PV, you will have a little pop-up help screen that Excel gives to you. The rate here in this example would have been 0.07 for 7%. The number of time periods that this compounding is happening would be 10. Payments is not applicable. There were no payments that we were talking about. It was just whether we were going to have a sufficient starting amount. Future value was $1 million, and type is not applicable for unless we're doing finance 201 type calculations. So you can use that in Excel to come up to the same answer. All right, that's just a couple tools for you. It wasn't meant to be a long webinar. Compounding, again, very straightforward. A lot of people are familiar with it. Discounting, somewhat counterintuitive at first glance, but not really that hard once you figure out the moving parts. And you can always double check your answer by turning around and taking what you've discounted to the present and compounding that and see if you come back to the same number that you started with. All right, I hope this has been helpful. This has been a quick little video on compounding and discounting. Thanks for watching.